Okay, and we're just going to quickly look at number 7. If we, when we look at the question first, it can seem a bit daunting. So I'm just going to work through it and see when we come across a problem that we haven't seen before, it's just a matter of breaking it down and following the steps that we usually have. So to begin with, when we read it, we see, well, hashtag U, the cardinal number of U is 30, the cardinal number of P is 16, and the cardinal number of Q equals 6. So I'm going to begin by drawing a simple Venn diagram. Okay, so there we have our Venn diagram. Now, if we read the question here again, it says, find with the aid of the Venn diagram the minimum value of P union Q complement, okay? And so that is obviously the area that we know as outer space. So this area here, essentially, okay? Now, in order then, so something there like that can be a little bit daunting. But if we think about it in terms of numbers, if I, for example, had 2 here in my intersection, well, then that would mean I'd have 16 minus 2 here, which is 14, and here I would have 6 minus 2, which would be 4. Now, if we add those together, 14 and 2 is 16, and 4 is 20. And so out here in outer space, I'd have 30 take away 20, which gives me 10. Now, so that's just with one example of a number, and we're going to draw another Venn diagram just to see then and compare number-wise what we would expect. So I'll just make this smaller, 1 second. Okay, so now here I am with my second Venn diagram. Now, say for example, if I choose 6 here, well then that would leave me with, well, 16 minus 6 in P only, which would give me 10. And here in Q I'd have 6 minus 6, which means there's no one there in Q on its own. And so again, here this time, well, 10 plus 6 is 16. So here in outer space I'll have 30 minus 16, which is 14. Now, so very clearly we can see a big distinction between our number in outer space here and our number in outer space here in P union Q complement. So obviously in the earlier diagram, our first diagram, this one here, P union Q is 10, much smaller than here. And also I note, well, in this diagram, the intersection was smaller than in this diagram. And so, just simply to show them with the aid of a Venn diagram how I could find the minimum value for here, well then I want the maximum here to be the biggest it can possibly be. So up along here, I want this area here to be the biggest that it can possibly be. And so the bigger here is, obviously the smaller in here is, versus down here. And so just to show that on a new Venn diagram, and so into this I'm going to have, going on what we just said there, that this I want to be as small as it possibly can be, so that this area here is as big as it can possibly be. I'm going to write in 0 into this. So that means over here on this side I would still have 16, and here I would have 6. So if I add those two numbers together, well, 16 plus 6 gives me 22. So here in outer space, in P union Q complement, I would have 30, take away the 16 is 22, which would give me 8. Okay, and so just to show that mathematically as well, could call that area X, as we have done numerous times before. And so I would have X plus 16 plus 6, well, that all equals to 30. And again, so here I have X, 16 and 6 is 22, and again that equals to 30. And in order to get X on its own, well, I need to take away 22 from this side of the equation, so I'm just going to have minus 22 here. And if I do that on this side of the equals, I must do it on the other side of the equals, and we know that 30 take away 22 is 8. And so that's the minimum value of P union Q. Okay, and so this time now in part 2, we are asked to find with the aid of a Venn diagram the maximum value, the biggest value that we can have here in outer space, in the biggest value for the number of elements in P union Q complement. And so I return again to the diagrams that I looked at here and here with from the last question, from part 1. And so I can see out here, well, here in P union Q, as this was smaller, the number in the number in P union Q in complement in outer space was also smaller. And so here the bigger number that we have in the intersection, that means less is kind of counted in the union, and so we have a bigger number out here in outer space in P union Q complement. And so actually, if I look here, I have 6 in the intersection. That's the biggest number that can go into that intersection. Why is that? Because in Q in total, we know that the elements are only 6. And so this is in fact the maximum value that we can have out in P union Q complement, okay, out in outer space. But we'll just draw that out again just to show it. Okay, and so here we have our bigger diagram. So again, we've hashtag U, the cardinal number of U is equal to 30. We have our 2 sets P and Q. Okay, and we know that the cardinal number of P is 16, the cardinal number of Q is 6. And so here, well, as I said, the maximum number that can go into the intersection is 6, because here we only have 6 elements in Q in total. So if I have 6 here in the intersection, that means I'll have 0 left here in Q only, because 6 take away 6 gives me 0. Whereas here in P only, I have 16 take away 6 leaves me with 10. And so in outer space, again, we'll call that X. And so this time we have, well, X plus 10 plus 6 plus 0, and that is equal to 30. And tidying that up, we see that we have X plus 16 is equal to 30. And again, in order to get X on its own, I must take away 16 from this side of the equals. And so if I take away 16 from this side, I'm also going to take it away on this side. And so well, 16 take away 16, they cancel, and I'm just left with X here. And that equals, well, 30 take away 16 is 14. And so that's the maximum number that I can have in P union Q complement. Maximum. Okay, now, and then we'll have a look now at our third part. So here in part 3, it tells us if hashtag U equals U, hashtag P equals P, hashtag Q equals Q, and P union Q complement equals X, show with the aid of a Venn diagram that if P is greater than Q and X is a maximum, then U equals P plus X. Now again, that looks a little bit like gobbledygook, so we'll begin by drawing our Venn diagram and labeling as they require. So outside, in the cardinal number of U, they have told us is equal to U. Here we have P, and we know that this time it's equal to small p. And here we have Q, and we know that that's equal to small q in terms of elements. And we're told that out here in P union Q complement we have X. And so they ask us then that if P is bigger than Q and X is a maximum, then U equals P plus X. Returning to part 2 of the question, we saw that when X was a maximum, that X was a maximum, so this area here was a maximum. What happened here? The intersection was always also equal to being as big as it could be. So here we know that x is down here in the outer space in P union Q complement, and we know that here 6, well, that was the total that Q was. So if I have Q out here, then I know I'm also going to put Q into the intersection, which means I'll have 0 here. And so then here in P, well, what will I have here? I'll have P minus Q. Now they want us to see, well, that U equals P plus X. And so we're just going to add our universe together in the way that we traditionally would with an X. And so very simply here, in my first I'll have P minus Q, and I'll just put brackets around that, and then I have plus Q. Now I could add on the 0, but there's no point, so I'll just bring, then I have my plus X from P union Q complement. And what do I know that that is all equal to? Well, it's equal to our universe, and in that case, or in this case, that's a small u. Now straight away I can see here I have a minus Q and a plus Q. So again, that's like minus €5 plus €5. They cancel each other out, and I'd be left with nothing. So I'm just going to cancel those out here. And so all I'm left with on this side of the equals, well, I'm left with my P, and I'm left with X. So I'll just bring those down, and I have P plus X, and I bring down my equals is equal to U. And again, that's exactly what we were asked to show in the question. So just to recap very quickly, when we looked at this question here originally, it can look quite daunting, lack of numbers, but all we had to do was draw two simple Venn diagrams with a mixture. One scenario where I had a small intersection and the other scenario where I had lots in the intersection, and then just worked with what I have just to see, well, what would give me the biggest thing here. So the important thing here, as we come to it, you can see that this was a junior cert question in 2011. The real important thing is that we don't panic, okay? I'm just going to write this down here as a rule. Don't panic, breathe, and it's problem solving. And this is what we can really kind of expect. There's going to be questions that we've never seen before on our paper, but we are just asked just to simply proceed as we normally do, just writing in the bits of information that we know, and then if there's no numbers, maybe that we would try one scenario where the numbers are quite small, one scenario where it's quite big, and then we can work from there.